Hey everyone, welcome to DataMillennials. I'm Atul, and in this video we are going to discuss about the correlation function from statics module in Python. So this correlation function returns the Pearson correlation coefficient of two inputs. Pearson correlation coefficient takes the value between -1 and +1 and it measures the strength and direction of the linear relationship. Now if we talk about the syntax of this correlation function, then we have the first data set which is x, then the another data set which is y, then we have this optional argument which is method, and this method argument by default is linear. So if the method is ranked, then it computes the Spearman's rank correlation coefficient for two input. But if the method is linear, which is by default over here, then it will return the Pearson's correlation coefficient for these two input x and y. Now you must be thinking is that when we should use linear over here as a method or ranked over here as a method. So whenever your data is ordinal, then you have to use ranked over here as a method because it will calculate the Spearman's correlation coefficient. Else you would have to use this linear as a method over here. So for using this correlation function, we have to note that the both input, which is x and y over here, must be of the same length. Otherwise, the statistical error will be raised. So let's take a very simple example of the Kepler's law of planetary motion. Okay, so let's write a program that explores the correlation between the orbital period of planets and their distance from the sun using the Python's statistics.correlation function, and it will help us to demonstrate the Kepler's third law of planetary motion. So we have orbital period over here for each and every planet and the distance from sun. So we have all the planets over here commented out, and their this orbital period is the number of days, and this is the distance from sun in kilometers in millions. Okay, now if you want to show the relationship that exists between this orbital period and distance from sun, then we can use this statistics.correlation function. In order to do that, first we need to import the statics module. So let me copy this import statement and put it over here. Then what we can do is that we can simply write print s dot correlation, and then we have to give the argument. So our first argument as x is orbital period, so we'll give orbital period over here, and then we have y dataset which is distance from sun. Now we have to think about this method, what we are going to use, whether we are going to use the Pearson correlation or Spearman's correlation. So let's say that I want to calculate it using the Spearman's correlation coefficient. So in method I'm just going to give ranked, and now if I run it, you can see that we are getting the correlation as 1.0. This represents a perfect monotonic relationship exists because of the distance from the sun increases, then the orbital period always increases in the same order. So for example, let's say that Mercury over here is the closest to the sun, thus it has the shortest orbital period, while Neptune, which is the farthest from the sun, has the longest number of days for orbiting the sun. Now what if I simply remove this method argument from here? So let me copy this print statement and put it again over here. I'm just going to remove this method. So if I run it now, you can see that we are getting the correlation as 0.988. So by default, the method is Pearson's correlation, which evaluates the linear relationship. The correlation between orbital period and the distance from sun is 0.988, indicating a very strong but not perfectly linear relationship. This slight imperfection is due to the fact that the relationship is better described by the Kepler's third law. So in conclusion, using this program, we can confirm that there is a monotonic relationship between the orbital period and distance from the sun, and This is a very simple example that how you can use the correlation function from the statics module in Python. Happy learning and see you in the next video.